Now in this angle modulation, we are going to do wide band FM. Wide band FM. So if you recall, I wrote S of t equal to AC cos 2 pi FCT plus beta sin 2 pi FMT. Okay? And we only discussed that for narrow band FM, beta should be less than 1, and for wide band FM, if beta is more than 1, then wide band FM. Clear, guys? So guys, when beta is more than 1, you cannot approximate this, right? If beta is more than 1, you cannot approximate this, and you are supposed to do something else. And that is the reason we have to understand few properties of Bessel's function. Okay? Bessel's function. Okay? So Bessel's function is a mathematical concept which says Jn of x equal to 1 upon 2 pi minus infinity to infinity e की power j x sin theta minus n theta e की power j x sin theta minus n theta and d theta. Okay? Then there are certain properties of this which is very handy when you are going to deal with wideband FM. So actually it's a full-fledged mathematics topic, but we are not going to study in detail because we don't need it that much. So first property, I will tell you two properties, and that two are only going to get used. So first one is Jn of x is equal to minus 1 की power n j minus n of x. Second property, guys, Jn square x, and n is running from minus infinity to infinity, is equal to 1. So if you can do this, then the time domain equation, which I am writing directly, don't ask from where it has come and all, don't get jazbati on that. The time domain equation of wideband FM signal is this. AC is outside, summation Jn beta, n is running from minus infinity to infinity, excuse me, cos 2 pi fc plus n fmt. So guys, this is your wideband FM equation. It might look a little scary as of now, but it's easy to understand. It might look scary, but it is easy to understand. And how will you understand? Simple. You just start putting these three values, minus 1, then put 0, then 1. You can put any number of n, but just put these three. So you get what? St equal to ... plus AC j minus 1 beta cos 2 pi fc minus fmt plus, you put n equal to 0, so you will get AC j 0 beta equal to cos 2 pi fct This is your carrier plus AC J1 beta cos 2 pi FC plus FM T, right? And plus so on. So if you have this and you want to draw this spectrum as well, so how will it look like? So I will draw only positive frequencies for the sake of convenience. So you know that because of this carrier frequency, you will get a term called AC J0 beta by 2. Yes or no, guys? Because of this term, you will get another impulse which is more like, upper sideband, and you will get AC J1 beta by 2. Okay? And then you get AC J minus 1 beta by 2 at FC minus FM, and then this formula will be used. Put n equal to 1 in property number 1, guys. So you get what? J1 and put x equal to beta. So J1 beta is equal to J minus 1 beta with a minus. So I can write J minus 1 beta, I can write it as J1 beta with a minus, which I am going to do here. So I will write this, but it will be minus AC J1 beta by 2. Guys, actually it would have been AC J minus 1 beta by 2 with a plus, but I changed it. Can you see it? Similarly, you will have another impulse, but since it is AC J2 beta by 2, so it will be on the top side, right? It will be also AC J2 beta by 2 because power is even. Even power will not do anything here, right? Minus 1 ka even is positive only. So guys, you can clearly see that this is FC plus 2FM, this is FC minus 2FM, this is FC minus FM. And similarly, you can have the mirror images, right? Something like this. Clear? And it will keep going, guys. It will be keep going. And that's why it is called as wide band FM. That's why it is called as wide band FM. Okay? Just keep in mind when n equal to odd means negative term. I'm talking about the spectrum. When n is equal to even, positive term. Good. Now guys, wideband FM has wide range of frequencies, so theoretically its bandwidth will be infinite. But do you really think that we can modulate a signal in such a modulation technique that its bandwidth is infinite? Then what will you do with the multiplexing technique? Because multiplexing demands that the signal bandwidth should be as low as possible, at the same time channel bandwidth should be as high as possible. So at somewhere we need to understand that how Bessel function is going to help us. So Bessel's function says that at a certain beta, as you go higher order term, then the amplitude, or you can say the power contained in those impulses are negligible. Okay? So what we'll do, we'll ignore those higher order terms, and then wideband will become little more practical. So write that comment. Wideband FM has, first thing first, has wide range of frequencies. Has wide range of frequencies. Okay. So this is like more on summary on spectrum. Summary on wideband FM spectrum. Okay. Next pointer. So you are going to please note it down everything. It's very helpful. The spectrum consists of carrier and infinite number of upper and lower sidebands. Infinite number of upper and lower sidebands. Third point, the theoretical bandwidth is infinite. The theoretical bandwidth is infinite. Next pointer, the magnitude of spectral components, depend on the Bessel function coefficient. Bessel function coefficient. So magnitudes of higher order frequencies are negligible. So that I already mentioned, right? That as you go higher order terms, magnitude is very less, that's why frequency is negligible. And that is going to define the way for your theoretical infinite bandwidth to practical some certain good bandwidth. Okay? Next point, we clean. Right? The Bessel function coefficient J naught beta becomes 0. So guys, these are the values when it gets 0. The Bessel function coefficient J naught beta becomes 0 when beta is equal to 2.4, 5.5, 8.6, 11.8 and so on. For these values of beta, carrier magnitude spectrum is 0. For these values of beta, carrier magnitude spectrum is 0. And the moment carrier is 0, you know what I am going to say now. Modulation efficiency becomes 100%. Okay? Now we'll guys do the power calculation. So write power calculation in wideband FM. Okay? So now guys, first let's find power at carrier frequencies. You know how to do that. You will take AC J naught beta and you will square and divide by 2. And you can also use R as antenna resistance. Similarly, we can also find power at Fc plus Fm. So we'll write AC square J1 beta by 2R. Similarly, we can also find power at Fc minus Fm. So it is also AC square by 2 R J minus 1 square beta. So if we keep adding like this, so what we'll get? AC square by 2R as common, J0 square beta, J1 square beta, J minus 1 square beta, and so on. So I can say that using property number 2, total power is just AC square by 2R, which is equal to carrier power. Look at this beauty, guys. Look at this beauty. That is just equal to carrier power. See. Now, all those who are in the session, can you tell me what has happened wrong in this? That your power is coming equivalent to carrier power. There is no change in the power of the carrier. It's same before modulation, it's same after modulation. What is the reason? Because in frequency modulation, we are not changing the amplitude of the carrier. Amplitude of the carrier remains unchanged, and that is the reason power in the carrier is AC square by 2R. Anyways, write that point as note. Right? Since in frequency modulation, the amplitude of carrier remains unchanged, hence total power remains unchanged, and power depends on the amplitude only. Power depends on the amplitude only. Hence, total power equal to carrier power equal to AC square. Now guys, put the heading. So we are going to find what is the transmission bandwidth. Theoretical bandwidth is infinite, but what is the practical bandwidth you are getting out of this? So there was one person who gave this idea, and that is known as Carson's rule. So write the heading: transmission bandwidth of FM signal, transmission bandwidth of FM signal using Carson's rule. Using Carson's rule. Using Carson's rule. Yeah, that's correct, Harsha. So what Carson did, he proved, right? Carson proved that bandwidth of the signal, is dependent on modulation index. Carson proved that bandwidth of the signal is dependent on modulation index, beta. Next point is said that the theoretical bandwidth, please write, the theoretical bandwidth is infinite, which I already showed you guys, but the bandwidth of the signal should be as minimum as possible to do multiplexing. So, insignificant frequencies should be eliminated. So, insignificant frequencies should be eliminated. Okay? Insignificant frequencies should be eliminated. So what he said, according to Carson's rule, beta plus 1 upper and lower frequencies beta plus 1 upper and lower frequencies beta plus 1 upper and lower, not frequency guys, sorry, side bands will have significant magnitude, will have significant magnitudes and contain 99% of the total power. of the total power. Okay? So the FM signal is passed through a band pass filter to eliminate the insignificant high frequencies. Okay? Let me take an example. Suppose beta equal to 2, then highest significant frequency would be, so you know that, right? Beta plus 1 FM, right? So beta plus 1 means what? 2 plus 1 FM will give me 3 FM, right? And similarly, the lowest significant frequency would be minus 2 plus 1 FM, so it will give me minus 3 FM. Okay? And obviously you can add, you know what, FC plus this and FC minus this. So it will be what? FC plus 3 FM and it will be FC minus 3 FM. So what would be the bandwidth, guys? It will be max minus min, means FC plus 6 FM, FC plus 3 FM minus FC plus 3 FM, cancel 6 FM. If you really want to write 6 FM in a different manner, think of this formula. Because anyway you are going twice beta plus 1 FM. I have just written this. This is your formula of bandwidth. I think this is what Harsha wrote also. Clear, guys? And this is how you can feel that how Carson's rule is coming. Go and read any book. You will not see this expression, this way of getting to the formula. Everybody will come and just tell you, okay, Carson's rule formula bandwidth twice beta plus 1 FM. But that's not the only thing. You need to understand the whole beauty behind it. So it is 2 beta FM plus 2 FM. And what is beta? We know beta is delta F by FM, right? So you can say that it is twice delta F plus FM, right? So bandwidth formula has become twice beta plus 1 FM, or it is twice delta F plus FM. Both are correct, guys. Please remember it. Any question? Anything, guys? It's a drill question. 100 megahertz carrier signal is FM modulated, okay, by a sinusoidal carrier, by a sinusoidal masses signal of 20 volts amplitude and 100 kilohertz frequency. Okay. Kf given is equal to 25 kilohertz per volt. 25. Question is, first part, calculate delta F, beta and bandwidth. Repeat the first part when masses amplitude is doubled. When masses amplitude is doubled. Come on, guys, attempt this question. So look, it is FM modulated by a masses signal of amplitude 20 volts, masses frequency 100 kilohertz, right? And KF is 25 kilohertz per volt. Now guys, beta is what? Beta is KF into AM by FM. Don't forget this. Or you also write delta F by FM. So KF is 25, AM is 20 divided by 100. So it is 5. So beta is 5. And guys, always check beta is greater than 1 or not. If it is greater than 1, then bandwidth is Carson's rule. Otherwise, it is just twice FM. So bandwidth is 2 beta plus 1 FM. So it is 2 into 6 into FM 100. So it is 1200 kilohertz, or you can also say 1.2 megahertz. Delta F already you can see. Delta F is how much? 500. Now if AM new gets double 40, so beta is what? AM new into KF by FM. So actually new beta will be double of old beta, twice beta, or you can also see here 40 into 25 divided by 100, so it is 10. So beta nu is 10, which I think a lot of people got. Bandwidth nu will be 10 plus 100, so 2200 kilohertz, and delta F will also change, it will become 1000. So you can clearly see that if you are changing AM, frequency deviation is doubled and bandwidth is also changing, but not like bandwidth is getting just double, because just double will be 2400 kilohertz, but it is lesser than that. There is a good thing to think about. But the moment you see that amplitude is getting double, amplitude is directly proportional to frequency variation, so variation will also get double, and that is what you are witnessing here. And if it is getting double, obviously bandwidth has a direct relation with the delta F. But one important thing that you missed, that it will not be directly double, because AM is also getting double, KF is also getting double, right? So it is how much? 1000 into 40 by 100, so it is some 400. Sorry, what I did? My bad. So no, I was doing something else. Because it's not a direct relation of double, so that's why.